Captain Jack in the house. It's Crewton Ramone's House of Math. We're doing math with Captain Jack. All right, so annoying math because they insist on making it hard.
Yeah.
All right, so now I got to hold my camera and do all this. So they want to just teach. No thinking skills, just cross multiplication. So of course they start off with the first one, which is you can't do it because you have to do cross multiplication because it's going to be fractional. But everyone after that, I just teach them, look, we're going to reduce and then figure out what needs to happen here. So 12/15 is the same as 4/5, right?
Yes, it is.
So how do I get to 20? Well, I have to multiply by 4.
Well, yes.
Same thing I have to do over here. I have to multiply by 4. So of course, 4 times 4 is 16. 12 to 15 is the same thing as 16 to 20. Or you could do it the hard way, 15y times 12 times 20, and then divide by 15 and do it that way, which is the way they're showing here. But like this one, how easy is that? 33 to 55. Well, 3 to 5.
Yes.
Right?
What's it?
Divide by 11, I get 3/5. So obviously. Okay, over here, I have 20 to 24 is the same as 5. Well, we just did some reduction there. But we very easily knew that 4 went into both of those, right? So you get 5, 6. So P must be 6. That's easy. How about this one? This is not as easy. We had to do some thinking here because we had to figure out how many 2's were in 16. That's 8. But how many 2's were in 34? And we actually counted out
8 to 18.
all the way out there. We counted. Oh, it's a little breezy today. We counted out to make it super clear. But actually, we did it fast because he's at the age where he can multiply. So we counted out. Look there. There, see him? There's a 34.
Yes, 34.
1, 2, 3, 4, 5. Well, that's easy. If that's 5, that's 5, and that's 5. And he kind of already knew that 2 went into 30 15 times. You knew that. And then he just had to count those last 2.
15 and 17.
There you go. And then when we did 36, 15, and then 3 more. What's 15 plus 3?
15 plus 3 is 18.
There you go. That was another problem, but anyway. So now, 17. How many 17s in 51?
There are...
Oh, we already did it, but we're making them do it again. How many?
5.
5 times 17 would be way too much. It'd be 85.
There are 2.
2 would only be 34. We figured that out.
Yeah, sorry, rehashing myself.
Okay. Yeah, I'm not covering the answer. So how much does it have to be?
4.
4 would be 68.
3.
3 would be 51. That's guesswork and it's lousy. But look, what do you think? 3 times 10 is 30 and 3 times 7 is 21. We got the 1 there. 21.
It's 21.
It is 21. It is 3.
Yes, 3.
So what's 3 times 8?
3 times 8 is 24.
There it is.
And...
All right, so now, how do we teach this? Because on this one, we'd have to... That's going to be difficult. And it would actually, to me, be easier to just multiply 25 times x and 15 times 38 and then divide by 25. There's fun stuff when you're... How old are you?
12.
See, and there it is. I'm teaching how to do it. Oh, just don't think at all. Just cross multiply. That's all we want you to do is just learn cross multiply, and then you'll forget it later. So here's what we're going to do. Let's play the game. Here's the game. Here's this game.
Yes, it's good.
You get... I get 3. You get 5.
Yeah, I get 5. Yeah.
So I put down a 3. What do you get?
I get 5.
There you go. That's easy. So 3 to 5 is the same thing as 6 to 10. That's good. All right. How about I put down another 3?
No, it's 15 to 9.
9 to 15, but yes. Your relationship is this to this. Okay. Oh, I'm gonna get crazy. What if I put down 2 here?
2 of them would be...
But today we're not done yet. We're gonna get even crazier than that. I'm gonna put down 4 of them. Oh my goodness. Now how many do you need down here?
I need 4 5s.
4 5s.
20.
You are correct, Mundo. All right. Kerblam.
Kerblam.
There it is. All right, so let's write this down. I got this lovely whiteboard over here. Will that focus on that? Yes, it will. All right, so let's take... There was an eraser here. Did you steal the eraser?
No.
I think you did. All right, this was another lesson on calculus and... Oh, look at that. It won't come off. Lovely. Sklurp. Oh no, now I need though I need to pause is what I'm going to need to do. Oh, no, here's a class. Okay. Oh, that's lovely. A lovely smear.
And it's the same color as a pug's face.
Is it? Pugs are kind of grayish black, is what you're trying to say? Alright. See, some pens don't work as well as others. Alright, so here I'm just going to write down using my symbols. 6 to
10.
6 to 10. 6 to 10.
9
is the same thing as?
9 is the same thing as 9:15.
9 to 15, and what's the last one?
Is 20 to 24.
Wait a minute, how many is there?
Sorry.
And how do you get 24 counting by 5s anyway?
Oh, sorry. That's 20.
Mm-hmm.
And
tell me the top one first.
the top one. Sorry, I really get dumb.
Just count!
Yeah.
I don't want to hear you telling yourself any self-talk about how you're not smart.
12.
3, 6, 9, 12. How many on the bottom?
20.
How do you know?
Calculated.
Counted them. Alright, so now all I'm saying is, look, let's just pick 2 of these and get crazy. Let's go with 6 is to 10 as, I don't know what, is to 20. Well, how do I figure that out? Well, here's what they want you to do. What they want you to do is just cross-multiply and get 10x equals 120 and then divide both sides by 10. No fun, get back to 1. That's an excellent way to do it. It works. And you'll get 12. Right?
Not wrong.
That's exactly right.
If you were...
Right, but here's what I'm saying. Here's an easier way to do it. Let's just reduce this fraction. What's the relationship between these two? Because math is a study of relationships.
6 and 10
is the same relationship as what to what?
Is the same relationship to 5.
Well, give me the top one first.
To 6.
Top one.
6.
Just this part.
Yeah.
How much is right there? Give me your finger.
That's 3.
And how much is this?
5.
Isn't that relationship 3 to 5?
Yes.
All the way across, isn't it 3 to 5?
Yes, it is.
Alright, so what I'm saying is, we're going to take this, and we're going to just reduce it to 3 to 5. Right? Now I know that to get there I had to go 2 times 2, right?
2
right?
2, yes. 2 times 2 is 4.
How far did it take? How many 5s in 20?
There are 4.
4. So over here I have to have 4 too. So 4 times 3 is what? It's just a rectangle.
4 times 3 is 12.
And that's that rectangle we're talking about. This side's 3, that side's 4. This side's 4, that was 5. We knew it was 20. Right? But we figured out that was 4, that side must be 5. That was 4, that side must be 3. This side must be 4. The whole thing must be 12. Right? That's how you teach it. To make it easy to understand the relationships instead of doing all this crazy cross multiplication. Right? And he'll get in trouble, I guarantee you, in school if he just did the cross multiplication way. Or I mean, if he doesn't do the cross multiplication way, and if he did it my way. So I'm going to have to. I actually have a note from the teacher that says that he has to show some cross multiplication and put it in his book.
Mm-hmm.
Okay, so we'll do this one because that's the only one that really requires it. And actually, we could do this. It's just fractional, right? Because it's 25 to 30, so I could put 5s in there. I could get 1 5 and figure out, no fun, get back to 1. I could figure out that, let's see, I divide by 5, and then I have to divide 38 by 5.
38 by 5.
38 by 5,
It's not possible.
Yes, it is possible. It certainly is possible. Watch me. Watch. 5, 10, 15, 20, 25, 30, 35... 38.
Oh, it is.
Oh, it is. So it would be 7 and some more. Alright, so let's figure out the some more part. I'd have 3 left over. And what was I counting by? 3 out of what?
3 out of 5.
So it'd be 7 and 3/5.
Fifths.
So if I do 7 and 3/5, what do I have to multiply 5 by to get to 15?
5, you'd have to divide by,
Multiply by?
multiply it by 3.
Okay. So what would I have to multiply my 7 and 3/5 by?
5.
Why would I multiply by 5? If I multiply by 3 there, do I ever multiply different from top to bottom?
No.
No. if I move over 3 up here, I have to move over 3 over here.
Yes, you do.
So if I moved over 3 over here, how many do I move over on the bottom?
15. You moved 35 or something.
Wait a minute, I moved over by how many? Here, you just told me.
3.
3. So how many would I move over on the bottom?
3.
3. But those are 3, 7, and 3/5 we have to do.
Yes.
We have to multiply it 3 times. Can you multiply 7 and 3/5 3 times?
7 and 3/5 3 times. Kind of hard, but I guess I can.
I guess you could. Try it. I'll help you, as usual. Let's take this little white space on the board here. And I'm going to have 7 and 3/5 times 3. Oh my goodness. Well, I know. What's 3 times 7?
3 times, 3 times 7 is 21.
Very good.
I like my annoying voice.
Alright, here's the annoying voice. What is underneath this grief? Alright. Oh my god. Okay. Little boys. Alright, so I multiply 7 and 3/5 3 times. I get 21. Now the tricky part. So that's 21. That's easy. Oops. This pen is just about done. Time to go make a little run to get more pens. Alright, so there's 21. Barely showing. What is... Hand me that purple pen over there. See that purple pen? I'll bet you that writes really well. What is... Yes, it does. What is 3 times 3/5?
3 times 3/5. 3 times 15.
What's 3 times 3?
3 times 3 is 9.
9. And what's the denominator going to be? If I multiply 3/5 3 times, what do I get? I get 9.
9. 5.
9 5s, exactly. 9/5. Right?
Yes.
How many 5s in 9?
1.
1. And how many left over? I'm just converting this back into a regular fraction. This is an improper fraction.
3 left.
1. How many left?
4.
And what were we counting by?
5.
5s. So now I just add my 1 and 4/5 to my 21, and I'm going to get... I got to add my 1 and 4/5 there to my 21. And what am I going to get down here?
Yes. 20.
We're adding. Come back.
Okay, 1.
You were having pug dreams for a second there, weren't you?
1, yes, I was. 1 plus 1 is 2.
There you go.
And 2 plus 2 is 4.
What? Where'd you get 2 plus 2? We're not adding this, we're just adding these.
Right.
Then what?
And 4 over, what's that?
What are you trying to say? You can't tell that's a 5?
Oh, yeah. You can't tell it's a 5, it's a little scrambled up there.
Alright, fine. Look how you are. If you wrote that, I would have to know. Alright, fine. Alright, so, this is a 5. Okay? 22 and 4/5. Done.
Yes, 22 and 4/5.
Now, what was that? All that math that we just did, by the time we got it all done and we did all the different parts to it, we lost track of the problem that we were doing, which was this.
Yeah, sure was.
So, x would be 22 and 4/5. Or you could do it the hard way and multiply 25x and 15 times 35 and then divide by 25. Should you so choose.
Yeah.
Alright. I don't choose to. Doesn't sound fun. Alright, so we need to do some more practice with blocks like this so you get the concept of what you're doing over here. So that if you have to take a standardized test or something, you can just do the math fast and easy as opposed to just learning rote memorization. So what are we studying? We're studying the relationships between these numbers. That's what ratios are, relationships. In fact, that's all mathematics. We study relationships all the time, whether it's trig or calculus or addition and subtraction or triangles or rectangles. We're studying relationships. Do you believe me?
Yes, I do.
All right.
Even though I sound like a thug.
You sound like a... Is that what... I don't think thugs sound like that. Okay. And we got more worksheet to do, but I just want to do one quick lesson on how to do that. And then one lesson does not a pro make. How many times are we going to have to do this? We're going to do this several times before he gets it. So let's do one. Let's do one quick while the while the camera is still rolling. 3 to 4 this time.
Yes, 3. It's 3 to 4.
Alright, so I'm going to give you a bunch of 4s because yours is the 4 deal. There's a bunch of 4s over there. He's got 4s. I've got 3s. So, 3 to 4.
3.
And here, we'll use this as our solidus. My side of the line, your side of the line. 3 to 4.
3.
The relationship is 3 to 4. Are we good? Alright. Look at me, I put 2 down. What do you do?
I put another 2 down.
Yeah, but you got 2 4s, right? Alright. We'll put them in there. We don't have all day. What are you doing?
Sorry, I'm the thug.
Alright, you're a thug. Okay. Wait, we'll increase our solidus out that way. Alright, now. I don't know. I'm gonna get nuts and I'm gonna put like 4 of them down. Now what?
4.
Now wait, stop. So here's my relationship. I'm saying that I have 3 to 4.
It's 3 to 4.
Stop. Pay attention over here. Alright. What do I have now? 6 to
6 to I'm really dumb. 6.
Next time you say dumb? Alright.
6 to
What is 2 4s? There you go.
8.
Now how many 4s are you gonna put over here? What I'm saying is now I have 3, 6, 9, 12. 12 to what?
12. Yes. 12.
Get your 4s and put them there and find out.
Yeah. That's free thugs. I like thugs, don't you?
I'm not a big fan of the thug, actually.
I'm
Although I have quite a few friends who are thugs. Bonafide. Alright.
1, 2, 3, 4, 1, 2, 3, 4. Pug. I'm 1.
East?
Yeah, what?
What? Tell me how many this is.
I'm dumb.
Oh, I told you, every time you say you're dumb, what happens? Alright, so.
That's 12 and 16.
Very good. Right?
Yes.
So 3 to 4 is the same thing as 12 to 16.
Yes,
It doesn't look like it, especially when I write it in symbols.
But still, it's the same
But
thing.
still, it's the same thing. Let's write it in symbols over here.
Exact same numbers, just
Yes.
different times.
Oh, yes, let's find my purple pen again. So here, all I said is, look, now if I took this one out, if I took this out, then I said, we just have this to this, and you had to figure out what's going on. That's why you want to reduce it. So I'm going to say, I have 6 to 8 is the same thing as 12 to, I don't know.
16.
But it's got to be 16. How do we figure that out? Well, we do our simple reduction here, and we see that this is the same as 3 to 4. Now, I can make rectangles if I want to,
No.
right? Because math is counting, and we count. Okay. So if I know that this rectangle is 4, this side has to be what? This whole thing's 8, one side's 4. What's the other side got to be? The whole thing is 8, one side's 4. What's that side right there?
A 4. That's a 3. That's a 2. I think I'm really dumb.
All right. Oh, there he said it again. I think you're doing that just so because you like getting a poke in the ribs. Yeah, I know it. All right. So now, what do we have?
A pug.
Oh, we don't have a pug. We have 3 and 6. What's that other side got to be? If the whole rectangle's 6 and one side's 3, what's the other side have to be?
It has to be 3.
3 times 3 is 9.
Oh, 2.
Okay.
I was going to say.
All right. So now I know this side's 3. Also, if the whole thing's 12 and one side's 3, what's the other side have to be?
The other side has to be
Count it.
12.
The whole thing is 12. One side's 3. What does the other side have to be?
3. 6.
Count 6 there or 3 there, and I'll give you $1 million. Bring me your finger. Count.
1, 2, 3, 4. Yes, there are 4 sides.
There are 4. If I have 3 is contained in 12 4 times. If the whole thing is 12 and one side's 3, the other side's 4. So now I know this must be 4 because I can't move the top without moving the bottom, right?
Yes.
Okay. So now, if I know that this is 4 and I know that this is 4,
it's 8.
Really? Because 4 times 4 is 8?
No, it's 16.
There you go. Oh, it's just going to take a little practice. You see how it is?
Yes.
See how it is?
Yes.
Now, I could have done this. I could easily have said 6x equals 96, and then taking that and divided, and taking that and divided, and that's the rote memorization, right? And they'll forget. I guarantee they'll forget it because they won't understand what they're doing. You're about to be in trouble, child.
Sorry.
All right. So, pay attention over here. 96 divided by 6. That's not as easy as 16 divided by 4, or 12 divided by 3. Keep the math simple. Keep it fun. 16.
That's why everybody hates math.
Why? Because they make it hard on purpose?
Yeah. And it makes me say I'm done. Wait, I just said I'm dumb.
Yeah, oh, there it is again! Ah!
Wait, I said it 2 times.
Oh, just 1 for 2.
And I just mentioned it.
That's all it is. All right, so sing me a song about pugs, and we'll be out of here.
Pug, 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 pug.
Really?
Pug, 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 pug.
Ride a Valkyrie. Sung in pug.
Pug, 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 pug.
Now we got wait a minute now. What is that? That's that's the glockenspiel right there. I had to play that on bells for Christmas, is why I know that. Anyway, that's hilarious. Okay, so do we need another lesson? I believe we do, because 2 of these certainly hasn't turned him into an expert, has it? Yeah. But if we do a few more, these will become easy and fun. Is this not so bad?
It isn't so bad. Besides saying I'm done, wow!
Yeah, cut it off. All right. Crewton Ramone's House of Math for more. Tell me it's not a good time here. This is your favorite place to come in the whole world, isn't it?